Hey everyone. Today we're going to learn what happens when we combine two things that we've already discussed. So we're going to look at story graphs and how story graphs can be combined with rate of change to make something we refer to as time distance graphs. With a time distance graph, we're going to know the story of a graph that we've already looked at. For instance, I could say that Kenny started 6 meters away from the wall and he walked slowly away from the wall for another 6 seconds. He then stopped for a period of time, 3 seconds according to this graph, and then he ran quickly back to the wall. So that's what we learned about story graphs the other day. What we're going to do today is we're going to add in the idea of rate of change so that we can be more specific about the functioning of this graph. And the details we can talk about are going to be time, distance, direction for each one of the line segments, and the speed. In terms of direction, we're already knowing this from our previous work that it's going to be talking about whether we're moving away from the wall or whether we're moving towards the wall. And speed now, we can deal with our rate of change to come out with what the speed would be. So we'll start with line segment A, and when we look at line segment A, we'll draw that rate triangle. As we draw the rate triangle, we can determine the rise and we can determine the run. These elements are going to help us to talk about the time and the distance, as well as the rate of change or the speed eventually. So for the run in this case, we can see that the horizontal length or the base of that triangle is 3, and it's 3 seconds on this graph. So in terms of the time, we can record that there have been 3 seconds taken up as the person travels along this line. The rise, on the other hand, needs to be found with the vertical length or the height of that triangle. And in this case, we can see that we're starting at 6 meters away from the wall and we're getting to 12 meters away from the wall. And the difference between those two numbers is again 6 meters. So our distance traveled along that line is 6 meters. In terms of the direction, since it's a positive correlation or an increase, we know that that means that the distance from the wall is increasing or the person is traveling away from the wall. We can use this information to figure out the speed. So to find the speed or the rate of change, we're going to need to do a calculation of rise over run. And we'll use that information that we got from up above. So we know that the distance is going to be the rise. We know that the time is going to be the run. So in this case, we have a rise of 6 and a run of 3. And when we divide the top number divided by the bottom number, the numerator divided by the denominator, we get 6 divided by 3 will give us 2. And don't forget that we always need to include units with a rate of change. So in this case, it's going to be meters per second. So there you have it. Along this line segment, we know that Kenny started 6 meters from home or from the wall. He then walked for 3 seconds and he went a total of 6 meters. He was traveling away from the wall at a speed of 2 meters per second. Since line segment B is horizontal, we can't draw a rate triangle. We know in this case that the speed is 0. This person is traveling 0 meters per second here because there is no rise. There is no change in the distance. The person in this case has traveled 0 meters from time 3 seconds to 6 seconds. If they had traveled any distance, then we would see an increase or a decrease in terms of the distance from the wall. The time can be reported though in terms of starting at 3 seconds and ending at 6 seconds. Again, this would be a run of 3. We know that on this graph, run is corresponding with the time. So we have 3 seconds that we can record as the time measurement for that line segment. In terms of the direction, there is no direction moving toward or away from the wall because the person is stopped. So if we were going to describe this line segment B, we would say that Kenny stopped for a total of 3 seconds. For this final line segment on this time distance graph C, we're going to draw a rate triangle once again. We would be able to label our rise and our run, and we can record the measurements appropriately. So we have a run of from 6 seconds to 9 seconds. That's going to be a run of 3 seconds. In terms of the distance, we're looking at a rise that is beginning right at the top here at 12 and going down all the way down to 0. So that means that we have a distance of 12 meters. This person, Kenny in this case, has gone all the way back to the wall by the time this line segment has ended. So his direction in this case is going toward the wall. His speed can again be calculated by looking at the rise over the run. Once again, on this graph, distance is the dependent value, so it's going to be corresponding with the rise, and time is corresponding with the run. So for our rise and run calculation, we're going to have 12 over 3. As we divide 12 divided by 3, we'll get 4, and again, it's going to have a unit rate of meters per second. So the speed that Kenny is traveling as he goes along this line is 4 meters per second, which is faster than the information that we found when we calculated the rate of change for this line segment when he was only traveling at 2 meters per second. And if you remember from our work with story graphs, the fact that this line is more gradual indicates that it's slower than line segment C, which is definitely a steeper line and therefore faster travel along that line. Hope this helps. You're going to explore more about time distance graphs as you look at some of your course notes today. Good luck. Don't forget to reach out and ask questions either via email or in the discussion board on D2L. Take care. Have a good day.